All right, this is going to be a help video that's pertaining to worksheet 6.2, which is all about percent composition. So the directions say find the molar mass of each of the following compounds and then calculate the percent composition for each. Use appropriate units for your answers and show work for any of the calculations. So first things first, we're talking about percent composition and what is percent composition? Well, if we look at this thing first, we've got potassium and chlorine. That's kind of the first thing to know. A lot of people students sometimes want to think that that's potassium and carbon and iodine. Unfortunately, with the font that we use, it's not really easy to show that it's ever carbon or iodine, or maybe it's chlorine. What I'll tell you, first things first, it's always Cl, chlorine. And if it's ever Ci, I would make sure to definitely tell you that. So anytime we see Cl, or Ci, it's not Ci, it's going to be Cl. So we have potassium and we have chlorine. Okay, and if we look at this, this potassium chloride thing, right? It's an ionic compound. It's made of a potassium, which is going to be the positive thing, and the chlorine, which would be the negative thing. And if we think about it, if you had this huge potassium chloride, ionic structure, there would be roughly 50% potassiums and 50% chlorines because it's in this kind of like 1-to-1 ratio, right? That's not what we're talking about here. I'm not talking about, hey, which percent is potassium, which is like 50% of the atoms, and what percent is chlorine, which is 50%. We're not talking about that. We're talking about percent composition by mass, okay? And yes, so there would be 50% by atoms, potassium, 50% by atoms, chlorine, but that's not what we're talking about here. We're talking about percent composition by mass. So the thing we need to know here is the mass of each of these things. Now, if you look at your periodic table, potassium is 39.10, and then chlorine is 35.45. I only have one of each of those, so I would, only need to multiply by one, or in that case, I don't need to do it. But we're going to look at a question later where if I have multiples of these, I would then need to multiply by whatever that number is, okay? So I need both of those numbers, how much does potassium weigh and how much does chlorine weigh? And then I need to add those two together, and I need to get the total number, which in this case is 39.10 plus 35.45 in your calculator is 74.55. With that information, right, this is the total, we can figure out what we know. Real quick here, it looks like potassium is a little bit heavier than chlorine. So what I'm going to guess here is the percentage of potassium is going to be slightly bigger than 50, and the chlorine is going to be slightly smaller than 50. And we know that because potassium is bigger in mass than chlorine. Let's do some math here. So with that information, I'm going to say 39.10 over the total. That's the percent of the mass of chlorine, or mass of potassium over the total, which is 74.55. Take that multiplied by 100. I'm going to do the exact same thing with the chlorine, which is 35.45 over the total. And we're going to take that times 100. And if you do that in your calculator, 39.10 divided by 74.55, and you multiply that by 100, what we should end up with is 52.45%. And if we do the chlorine, 35.45 divided by the total, 74.55 times 100, you're going to get 47.55%. And one of the ways we can check to see whether or not we did this correct is kind of go through this logic and be like, hey, is potassium heavier than chlorine? Well, then that means that the percentages should be a little bit bigger, and that's what we see for potassium. The other way we can do this, if we add those both together, 52.45, 47.55, we should get 100% of the pie, or 100% of the pizza, or however you want to think about that. But we should have 100%. And if it's not 100%, hopefully it's really close, like 99.9%, which would just be a simple rounding error. So that's kind of how you do the first one. And then if we look down here to the second one, we're looking at barium and nitrogen, and oxygen. So it's called barium nitrate. We need the masses of these things, 137.33. There's only one of them, so it's just one. Nitrogen, 14.01. But because I have this 2 on the outside, everything inside is going to be multiplied by 2. So that's going to be multiplied by 2. If you did that in your calculator, you'd get 28.02. And then I need the mass of oxygen. Students a lot of times want to add those numbers together, but that's not what that means. That means that I have 2 of the nitrates. I have an NO3, and then I have another NO3. So that's what that 2 indicates. So in this case, I would have oxygen times 6. So that's oxygen times 6, which is 16 times 6. And if you did the math there, that would be 96. If you add, that's the mass of barium, that's the mass of nitrogen, that's the mass of oxygen. And if you add all 3 of those together, you're going to get 261.35. Okay, so we have the mass of the total, and we have the mass of each of the parts. If you do the math here, you're going to end up with hopefully the largest percent of barium, right? That'd be the largest. Kind of second place would be the mass of oxygen, and then the smallest percentage is going to be the percent by composition by mass of nitrogen. So again, set this up real quick, 137.33 over the total times 100. Same thing again for the nitrogen, 28.02 over the total times 100. And then the last one, 96, which is the mass of all the oxygen over the total, 261.35 times 100. Again, the answers to these, if you add up all those answers, should equal 100%. I've actually already done the math for you. We've got about 52% of this. We've got 10.7% of this, and 36.7% of that. And if you add those all up, 52 plus 10.7 plus 36.7, you get 99.4. So let me check this, 337.33 divided by 261.35. Aha, it's actually 52.5, so 52.5. And so now if you add all those up, 52.5 plus 10.7 plus 36.7, you get 99.9, right? And so we are really, 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 really close there, 99.9%. Maybe that's an 8, or maybe that's a 8. And so we're within a rounding error. And sometimes that's just how it works out. Even if you round everything perfectly, you still end up with like 99.9 or even 100.01. So that's kind of the deal there. Remember to, multiply. If it's not just, we add those together. Nope, we multiply them. So it's 6 oxygens. When we go up to this one up here, 4 bromines. And then up here, remember, 2 sodiums. Okay, so there's some more questions on the back, of course, here. Make sure to multiply by those. And if you have any questions, please ask. Please let me know. Hopefully that was helpful. And again, this is worksheet 6.2.